Hello students, welcome to Learner's Planet, our session of chemical reactions and equations. In our previous session, we discussed about oxidation, reduction, oxidizing agent and reducing agent. And of course, few examples of this oxidation and reduction reactions. Like this was the example for oxidizing agent and reducing agent. In this case, your H2S is acting as a reducing agent and sulfur dioxide is acting as an oxidizing agent, right? I'll discuss few more types of reactions, that is irreversible reaction. Now students, you must have seen certain reactions which proceed in single direction. That is, we know that in a chemical reaction the reactants are combining and they are forming what? Products. So in an irreversible reaction, it is a chemical reaction which proceeds in single direction. What do you mean by single direction? That is, reactants form products, but products cannot be converted into reactants. Let's take an example of carbon plus oxygen gives carbon dioxide. So in this case, carbon reacts with oxygen giving carbon dioxide. But this carbon dioxide cannot be reversed back to carbon and oxygen. It is one way. Like we took example of iron reacts with oxygen giving iron oxide, that is Fe2O3. Here it was thrice of O2, 4 Fe and twice of Fe. Now in this case, what is happening students? That your reactants are being converted into products. There is no conversion of products into reactants. So the reaction proceeds in single direction and it is an irreversible reaction. Another type of reaction is a reversible reaction. That is, in which reaction can reverse itself. What do you mean by this? Reactants form products and products can be converted back to reactants. Now, how could you depict these two things? How could you depict the reversible reaction? Can be depicted by either an arrow with a double head, or I can write a double arrow here, that is going this side and the other one going this side. So this is a reversible reaction. For example, your hydrogen reacts with iodine giving 2HI. Now in this case students, hydrogen is combining with iodine forming hydrogen iodide. Now if I reverse the conditions, we all know that for a chemical reaction to occur, there is a certain set of condition, that is particular temperature is required, pressure is required. Now if I reverse the conditions, what will happen? Hydrogen iodide can again form hydrogen and iodine. Say for example, if I have high concentration of hydrogen and iodine, the reaction is proceeding in forward direction and it is forming 2HI. Now point comes when there is high concentration, if I am not removing the products, what is the products formed here is hydrogen iodide. Now if I am not removing it, what will happen? The concentration of hydrogen iodide will increase. Now in this case, what is happening? You have got high concentration of hydrogen iodide. Now where the reaction will proceed? The reaction proceeds in backward direction. That is, your HI will be converted back to H2 plus I2. So this is an example of reversible reaction. I'll tell you one more example, that is phosphorus trichloride. What will be the formula of phosphorus trichloride? The symbol of phosphorus is P, chlorine is 3, tri is 3. Chlorine is Cl, sorry, and tri is 3. This is combining with chlorine, that is Cl2, and it is giving PCl5. Now students, if I change the reaction conditions, what will happen? The reaction will proceed in reverse direction. That is, PCl5 will form PCl3 plus Cl2. So these are the two types of reactions, reversible and irreversible reactions. Examples of reversible reaction. When steam is passed over red hot iron, magnetic oxide of iron is formed and hydrogen gas is formed. That is iron, this is steam, and this is something which is wrong here. We have to put a double arrow like this. Well, what it is forming is, it is reacting with steam, it is forming ferric oxide and hydrogen. Now the second reaction, or it is, if hydrogen gas is passed over magnetic oxide of iron, what is the magnetic oxide of iron formed? Ferric oxide. The reverse reaction takes place, producing iron and steam. So it is a reversible reaction. Now what I can do is, I can put another arrow here. So this is a reversible reaction. Now students, we have done all the types of reactions, the combination, the decomposition, the displacement and the double displacement. There are oxidation and reduction reactions also. Now oxygen, as it is present in air, so this oxidation has got effect on our day-to-day life also. This oxygen has effect on metals, on food articles, in a way all our chemicals around us. Now, effects of oxidation reactions in our daily life, in everyday life. Say oxidation. Oxidation has a damaging effect on metals and food. The damaging effect of oxidation on metals is called corrosion. And that on food is called as rancidity of food. Now let's first discuss what is corrosion. Many metals are chemically active elements. Chemically active means they react at a very fast rate and get easily affected by factors like moisture, air, acids, etc. Let's take one example. When an iron object is left in damp air, a layer of red-brown substance is formed. This is called as rusting of iron. Students, this is a very common phenomenon, right? Now you must have seen iron with a coating of red layer over it. If you scrub it, it goes off. Now what is that layer formed of? Let's see, what is that layer formed of? Rusting of iron. During corrosion, what happens? Iron is oxidized by the oxygen of air. Again oxidized, oxidation, that is addition of oxygen. It is oxidized by oxygen of air in the presence of moisture. Of course there is moisture. You have kept your cycle or any other iron object in the atmosphere. So there is moisture and there is oxygen. So both this oxygen and moisture form what? Hydrated iron oxide. This is XH2O. XH2O. Now this substance which is formed on the surface of iron is soft and porous substance which falls off from the surface of iron metal. Yes, when you scrub it, this substance falls off. So when there is a corroded iron or there is rusted iron object, what we normally do is we scrub the surface. Now when we are scrubbing the surface, what we are doing? We are removing that iron oxide deposited. Now with iron oxide, what is happening? Iron is also being removed. So that is, with this substance, that is Fe2O3xH2O. This is what? This is a brown substance formed on the surface of iron. Now when I am scrubbing it, what am I doing? I am just removing this substance. Okay. So in a way, what is done is, iron is also removed. When iron is also removed, what will happen? Slowly, every time that brown substance is formed, you will scrub it. So slowly what happens, that the rusting eats up whole metal. Slowly rusting eats up whole metal. So this is about rusting of iron, which is a very common phenomenon, especially in rainy season. There are other metals also which undergo corrosion. That is copper vessels. You must have seen, children, when your copper utensils are exposed to air, what happens? Or if the copper utensil is kept for long time, what happens, students? That there is a formation of thin layer over it. That greenish layer is formed. Now what your mother does to wash it, either you'll take that material which is used for washing. What is it called? Brasso? No, it's not brasso. It is pitambari, which is normally used for washing. You must have seen in your houses. Then with that pitambari, it is scrubbed off. Or you can take some lemon and salt. That also removes that layer. Now what is that thin layer composed of? That thin layer is composed of copper carbonate and copper hydroxide. How is this formed, students? It is formed by the reaction of copper metal. We have seen that copper is active metal. Copper metal with carbon dioxide of atmosphere and hydroxyl of water. So by this reaction, your thin layer of copper carbonate and copper hydroxide is formed. Now every time that is scratched off or every time that is washed, what happens? Few copper particles are also removed. Slowly what will happen? The layer of copper utensil will become thinner and thinner. So this is also eating up of metal. There is another metal which undergoes rusting, and that is silver. Silver also, there is a black layer formed over the silver utensils like glasses or bowls or silver ornaments. Now what is that black layer of? It is of silver oxide. Now this silver oxide is formed, and every time again you will remove it, your metal will get thinner and thinner. So this is tarnishing of silver. So students, these are actually active metals, active elements like iron, silver, copper, and your aluminium, of course. Aluminium, big aluminium drums or containers are there in your homes. You can just check it out. There is a black layer formed over it. It's not actually layer. There are black patches over that aluminium container. What are those of? That is aluminium oxide. Now students, every time this corrosion or rusting is not harmful. In this case of aluminium, that black layer of oxide is formed, and that is aluminium oxide. So that black layer formed over aluminium, this black layer formed is what? It is aluminium oxide, Al2O3. This is also what? Rusting or corrosion. I can say that it is corrosion of silver. But here what is happening, children? This rusting helps aluminium or corrosion. What has happened? That there is a protective layer of aluminium oxide over it. Now this aluminium is a highly reactive metal. It is very reactive. Now what can happen? If this protective layer is not formed, this aluminium will react with every component of air. So this layer, aluminium oxide layer, forms a protective covering over it. Had this been the protective covering not been there, it would have reacted with water also. And this aluminium with water will form what? Will form aluminium hydroxide. That is AlOH thrice. What I can put here is, there is twice of AlOH thrice. I can put here 2 and I can put here 3. So it is, what I can do is, I think I should put here 6H2O. Then the equation would be balanced. Now you also know how to balance. So you can point out, ma'am, you have done a mistake. So it is 6H2O. So this is 6H2O. Now there will be, it will react with water and it will form what? Aluminium hydroxide. Now this aluminium hydroxide is what? It is a compound which is formed by aluminium, and it will attack the edible food which you are keeping in aluminium containers. So this aluminium oxide protective layer in a way protects your edibles. Now we have got another metal which is gold. Gold ornaments your mother would be wearing, or you can see gold ornaments. There is never such layer formed. Neither it turns black nor it turns green. It's always yellow. Why? Because gold is less reactive than iron and silver. So your gold is less reactive. So it doesn't react with the elements or compounds present in moisture or air. So this is a repercussion of corrosion in our everyday life. Now there is another consequence of corrosion, that is rancidity of food. Now what is rancidity, students? When foods prepared in fats or oil is kept for a long time, they give unpleasant smell and taste. Now if you keep your French fries or your pizzas or cakes for a long time outside, what happens that it smells and tastes bad. Why? Because the oxygen present in the atmosphere reacts with the fats, and this unpleasant change in flavor and odor of food is called as rancidity. This odor spelling is wrong here. It should be ODOUR. Okay? And our next slide we'll see causes of rancidity. What happens? It is caused due to oxidation of fats and oils in the food. How oxidation? Oxygen atom replaces hydrogen atom in the fatty acid molecule. In fatty acids, there is oxygen as well as hydrogen. So in the fatty acid molecule, what all are there? There is hydrogen. So that hydrogen is replaced by what? Oxygen atom of the surroundings. So this causes the oxidation of fats and oils. Now factors which accelerate fat oxidation include salts, light, water, bacteria, molds and trace elements. Trace elements, what do you mean by trace elements? These are the elements which are present in very, very small amounts, in micrograms you can say. Now students, you must have seen cashew nuts or almonds. They also become rancid. This is because of the high lipid content of these foods. Now I'll tell you what is lipid. Lipids are what? Fats or lipids. These are long chain fatty acid molecules. Or there is, say, I am writing fatty acid. Fatty acid is what? There is a long chain compound, that is CH2, CH2, CH2 and COO minus. Now this is bonded to some glycerol molecule. So these are long chain fatty acids. Now in this thing you can find out, students, that these are hydrogens in the chains. Now these hydrogens are replaced by what? Oxygen. Now your chain will be every hydrogen, in place of every hydrogen there will be oxygen. So that excess of oxygen gives that unpleasant smell. Okay? Now how can we prevent rancidity? Rancidity is something like you have your food is spoiled. Why it is spoiled? Because of the action of oxygen on fatty acid. What action of oxygen takes place? Hydrogen is being replaced by oxygen. Now there are certain chemicals which can, what they can do is, which can prevent this oxidation. Now usually the substances which retard fat oxidation, retard means decrease. Fat oxidation or rancidity are called as antioxidants. Now these are DHT, DHA, vitamin E, vitamin C and spices. Rosemary, that is a herb. Sage, it's a herb. Now these are added to foods containing fats and oil to prevent such spoiling. Now if we add all these compounds, what we can do is we can prevent the spoiling. Vitamin E, vitamin C. By doing this we can prevent rancidity. How else we can prevent rancidity? By keeping food in airtight containers or airtight wrappings. Now if you are keeping your food in airtight container or wrappings, what will happen? There will be no action of moisture or oxygen on the food. If you keep cashew nuts or almonds in airtight container, what will happen? The activity of oxygen on these foods is reduced. How else can we prevent rancidity? By keeping food in refrigerators at low temperature. Now how it prevents rancidity? At low temperatures what happens? That the rate of reaction decreases or the reaction becomes slow. For every reaction, students, what is happening is there is some breaking of bond and there is some formation of new bonds. Breaking of bond and formation of new bond. What it requires? It requires energy. That energy is supplied by heat or in a way by rising temperature. So if we are reducing temperature here, what can be done is that this oxidation process can be retarded. There is another method, that is vacuum packaging, to avoid the presence of oxygen altogether. Vacuum packaging is used in self-processed food stuff. Vacuum packaging, now what do you mean by vacuum? Vacuum is where there is no trace of gas. Okay, no trace of gas means neither there is oxygen, nor hydrogen, nor nitrogen, nor any gas. None of the gases are there. So that is vacuum packaging. So if we vacuum pack a substance, what will happen? There will be no trace of any other gas. So oxidation is again retarded. Your Lays or your chips, your kurkure, what you eat, or your Cheetos, all these are vacuum packed. There is no trace of gas. So unless or until the packet is opened, the food inside will remain as it is. By vacuum packing, we can avoid rancidity. Now there is another method, that is by storing foods away from light, as the oxidation of fats and oils is slowed down in the absence of light. Light again is giving a form of energy. Now if we are storing it away from light, if we are storing it in dark, there will be no source of energy and your oxidation can be retarded. So these are few methods to prevent rancidity. Now can you guess how could you prevent iron from getting corroded? We just put a layer of paint over it. If I am putting a layer of paint over it, what is happening? That your iron is not exposed to the air directly. So in this way we can prevent corrosion of iron, and these are the methods for prevention of rancidity. So this concludes the topic of chemical reactions and equations. In this topic we dealt with what is about the physical change and the chemical change. Moving on to what is a chemical reaction. Then we discussed about the features of chemical reactions, that is how the chemical reaction proceeds, or how you can get to know about the chemical reactions by evolution of gas, by change in color, by precipitation, or by change in state of matter. Then we proceeded how to write a chemical equation from a word equation. Then we balanced the equation. Then finally we discussed the types of chemical reactions, that is the combination, the decomposition, the displacement and the double displacement. We also discussed about oxidation and reduction, and finally we discussed about the applications or the repercussions of this oxidation phenomenon on everyday life. So that students, this completes our topic. In the next session, we will solve problems related to these topics. So students, practice all the things so that you can attempt the questions which we are going to solve. So until our next session, practice all the things which we have done in this chapter.